for the first topic in this module, we're going to talk about multiplying and dividing radicals. In order to do this, we need two, rules or two properties of radicals called the product rule and the quotient rule. So let's look at those. Okay, so remember, radicals are rational exponents. Okay, the square root is the same thing as the 1/2 power. So it shouldn't surprise you that our exponent rules that we talked about a while ago translate into radical rules. So in fact, the product to a power rule that we had before translates into what we call the product rule for radicals. Okay. If you read the rule from right to left here, it says when you multiply a to the m times b to the m, you get a times b to the m, which means a and b are both being raised to the m power. It's a similar rule for radicals. If you multiply the nth root of a times the nth root of b, you can just multiply underneath the radical expression. So you get the nth root of a times b. Then we have a quotient rule as well. Okay, the quotient to a power rule from our exponent rules translates into the quotient rule for radicals, which says if you divide the nth root of a by the nth root of b, you can change that division into division underneath the nth root. Okay, so these are the two rules we're going to use to multiply and divide radicals. So in words, here's what the product rule says. The product rule says to multiply two nth roots, multiply under the radical symbol. And in words, the quotient rule says to divide nth roots, divide under the radical symbol. All right, so here are a couple examples so you can see how this works. In the first example, we have the cube root of 4 times the cube root of 16. So to multiply two cube roots, we're going to go ahead and transfer this multiplication underneath the cube root symbol. So the cube root of 4 times the cube root of 16 is the cube root of 4 times 16, which is the cube root of 64, which we know is 4, because 4 times 4 times 4 is 64. Similar, we can divide two cube roots, or any nth root, by switching the division symbol and putting it underneath the radical sign. Okay, so the cube root of 81 divided by the cube root of 3 is the cube root of 81 divided by 3, which means we get the cube root of 27 after we do this division. And the cube root of 27 is 3 because 27 is 3 times 3 times 3. Okay, so that's, in practice, that's how the product and quotient rules for radicals work. We'll have more extensive examples in a second, but I wanted to give you a couple of baby examples so you have an idea of what we're dealing with here. On to example 2. Use the quotient rule to simplify each radical. Assume the variables represent positive values. So part A, there's C parts again. Part A gives you the square root of w to the 10th divided by 64. Now, to simplify this, we're actually using the quotient rule in reverse, I suppose. Let me show you what I mean. Here's the quotient rule for radicals. It says if you divide the nth root of a by the nth root of b, you get the nth root of a over b. Okay. But if you look at what we're given, we're actually given the square root of a over b already. We're given this side. So to simplify this, we're going to go ahead and move backward and split the radical up. Okay. That's going to help us out because if we split this radical, we can then simplify. Right? If we split the radical, we get the square root of 64 and the square root of w to the 10th. Those we can deal with. So let me show you what I mean. So the square root of w to the 10th over 64 becomes the square root of w to the 10th divided by the square root of 64. And then each of these we can simplify individually. Okay, we know the square root of 64 is 8, because 8 times 8 is 64. And we know the square root of w to the 10th is w to the 5th. Right? You have 10 w's inside this square root that you need to break into groups of 2. 2 goes into 10 5 times with no remainder. So you're going to get a w to the 5th on the outside, nothing left on the inside. By splitting up the square root, we were able to get rid of it altogether. So this is our final simplified answer, w to the 5th divided by 8. Alright, so part B of example 2 gives us another quotient to simplify. Okay, but this time it's a cube root. We have to break down the cube root of t over 125. So we're going to apply the same principle. The cube root of t over 125 is the same thing as the cube root of t divided by the cube root of 125. Why did we do that? Well, we can actually simplify the cube root of 125, right? We know that 125, if you factor it down, has 3 5s. So since 125 has 3 5s, we know that the cube root of 125 is just 5. So by splitting up the cube root, we were able to simplify the denominator. The numerator, however, we cannot simplify. It stays the cube root of t. Right? I need a group of 3 t factors in here, and I only have 1 t factor. So that's as far as we can go. Okay, part C gives us a 5th root to deal with. We have the 5th root of the quotient 32 over z to the 15th. Go about it the same way. Break it up into 2 5th roots being divided. The 5th root of 32 divided by the 5th root of z to the 15th. Then try to simplify the roots individually and see if you can get anywhere. Okay, for the 5th root of 32, I have to break 32 up into prime factors and see if I have any groups of 5. So let me do that down here. So indeed, when you break 32 into its prime factors, you see that you have 1, 2, 3, 4, 5 2's. Okay, so the 5th root of 32 is just equal to 2. That group of 5 identical factors comes out as a single. So up here in the numerator of my fraction, I'm going to put a 2. Next, we have to talk about the 5th root of z to the 15th. So this guy's got to get simplified. If you do the 5th root of z to the 15th, you're looking for groups of 5 factors. So we're going to break our 15 z's into groups of 5. 5 goes into 15 3 times with no remainder, which means that we're going to get a z cubed on the outside and no z's left on the inside. Okay, so the 5th root of z to the 15th actually breaks down into z cubed. So up here in our fraction, we're going to replace this 5th root with z cubed. And that's it. We've simplified as much as we can. The 5th root of 32 over z to the 15th breaks down into 2 over z cubed.